Hello everybody! If you've seen the title of this video, TikTok, or you're listening to it now, you're probably thinking, is that a bad ripoff of the app? No, you can think of it as TikTok, like on a clock. So what I'm going to do is I'm going to type the word tick into MATLAB, and nothing has happened. But I'm going to talk to fill up space because soon you will see what happens. So what tick does is you can imagine that it starts a stopwatch, and then when I type the word talk, T-O-C, what this does is it tells me how much time has passed since I typed or entered the word tick. Now, what's going to happen if I type talk again? So what this has done is it's measured how much time has elapsed since the first call of tick. So it's not kind of the time between kind of this talk and this talk, it's the time since the last tick. So again, I can say tick, press enter, and I could say like 1, 2, 3, 4, maybe 5, and then I can press talk, and we can see, okay, little under 6 seconds. Cool. So you're probably wondering, why do we deal with this? Why do we care? Well, most of what kind of we care about when we're writing algorithms and functions is how fast are our functions. We don't want them to take more time than necessary, and we always kind of have the goal of improving our functions to be faster. So in a future video, we're going to be plotting kind of vector length against how long it takes a function to do something. And what we can do is we can say y equals talk, for instance. And what this does, it returns the numerical value of the time elapsed. So if you don't want it to have the English words around it, and you just want the numerical value, you can assign y to the variable talk. So this is all fine, but using tick and talk in the command window is generally not something you're going to do, just because we're mostly interested in timing scripts and functions. And also keep in mind the time that it takes me to type, tick, and talk. So if I'm really trying to measure how long a function or something takes, I don't want to include the time that it takes me to type the words tick and talk, right? So for those reasons, most of the time we're going to be seeing these within scripts and functions. So what I'm going to do is I'm going to create a new script. And let's see, I'm going to set a variable z equal to 13. And what we're going to do is I'm going to create a very, very large vector. And then I'm going to write code that's going to search the vector for this value 13. And then we're going to time how long it takes. So I'm going to start by saying, okay, let's let a vector v be 1s, and let's make it 10 to the 7. And the reason why I'm kind of making such a large vector is I don't want it to be too easy for MATLAB to find this value z in the vector, so I want it to be kind of a non-trivial search. Then what I'm going to do is I'm going to make the vector v, it's going to be v comma z comma v. So basically I have 10 to the 7 elements, then I have 13, then I have 10 to the 7 elements afterwards. So z is kind of right in the middle of this very long vector. Then what I'm going to do is I'm going to type the word tick. Now, this is only going to run once we run the script and once the script gets to line 4. So we don't have to worry about it running now or anything like that. Then what I'm going to do is now type the code for searching for this value z within the vector. So I'm going to use b to be Boolean value, so we're going to initialize it to false. And you can think of this as representing true or false. The value z equals to 13 is in our vector. So we're going to initialize it to false. Then what I'm going to say is for x equal to v, oops, not double equals. Now we're going to have if x is equal to our value z, then we're going to set the Boolean value equal to true. So if we find the value z in our vector, then b is equal to 1, it's true. Then we're going to end the for loop and the if statement. And then once we exit the for loop, I'm going to kind of return the time talk. Then what I can do is I can display, just so that we make sure that we've done everything correctly. So we should get the value 1 just because I have forced z to be in this vector v. So how about I save this as, let's call it timing. script. And now what I'm going to do is I'm just going to run it. So let's run timing script. And we can see here that it took 0.28, about 0.28 seconds, and the value b is equal to 1. That's returned because we were able to find the value 13 in the vector. So now something that we can do is, well, we tried it for 10 to the 7th. What if we tried it for something like 10 to the 5? And we can run it again. And we can see here it takes a lot less time. So if we give it kind of a shorter vector, it takes less time. A longer vector, it takes more time, as you can imagine. Now let's try maybe 10 to the 8th. And it's going to take a little bit longer just because, again, larger vector. And we can see here now that the elapsed time is 2.8 seconds. So something I want to draw your attention to is notice this first example we ran. This was with 10 to the 7. And this one here is with 10 to the 8. So if we increase it by 10 times, the time also increased by 10 times, right? Because we just moved the decimal one place and we get 2.8 seconds. So this is suggesting that the time it takes to go through our for loop is linear. If you end up taking an algorithms class in the CS department, for instance, kind of the concept of how long it takes to go through a function is very, very important. And you'll come across kind of like the big O notation and things like polynomial versus exponential time. Not super important for our class, but it's just good to know that these terms exist. But one thing that is important for our class is we can ask, well, how can we make our function faster? So if we go back up here, there's one really simple way to make this faster, and we've already introduced it. So maybe some of you, when you were watching me write the first for loop, were wondering why I didn't include this. But remember, all we care about is the value z in the vector? And as soon as we find it, we can just terminate the process, right? So I can type the word break here, save it, and now let's see what happens. So again, here I'm still dealing with 10 to the 8. And now I can run timing script again. And we can see here it took about half the amount of time as when we didn't have the break. So you might be thinking just including break made it kind of twice as fast. But the reason is basically because we put the value z right in the middle of the vector, right? So it's not break that's making it fast, it's where z is in the vector. So it's right in the middle, so we would expect it to take half the amount of time. Last thing to notice is, remember, we're working in a script here, so it wouldn't be right to put the word return here because scripts don't return anything. So we would only use return in a function. I know in our break and return video, break and return seemed almost the same, but just a quick kind of reminder that we're working in a script here, so we just want to use break. So thanks for watching, everyone. We'll kind of do more with this timing in the next couple of videos, and I will see you there.